Here we go. So guys, here's the scoop. You need to grab something you can take notes with. You need to grab a calculator. And I'm going to teach you another skill today. Guys, I put quantitative problem solving on the board because if I put dimensional analysis on the board, which is actually what we're doing, I know that I would immediately drive some of you out of this conversation because you learned dimensional analysis and physics and either you didn't understand it or you hate it. Or both. Or you hate it because you don't understand it. Guys, here's the way this is going to go down. You are immediately going to be cast, because of what we're doing today, into one of three groups. You're going to be bored, you're going to tune out, or there is the possibility that you may actually learn something. Now guys, the trick is this. If you think you're going to be bored, you did this in physics, whether you liked it or not, you understood it, guys, you've got to understand that there are details in this process that I'm about to teach you that Leosa does not teach, and you've got to know it. So, if you think you're going to be bored, initially that may be the case, but hang on, you're going to learn something. Now guys, if you're tuning out because you're going either this is a waste of my time or I never could understand it in the first place, guys, understand I'm going to get you to the point where you get this, and you might even like it. But guys, understand what that means then is everybody's got to get into this camp where for the next hour and 10 minutes, guys, we're doing this together, teaching you this skill. Now, the way that I'm going to teach you this skill is I'm going to do it by asking you a question. And what I'm going to ask you to do in the next 3 minutes is figure out the answer to this question as it applies to you. And your notes paper will become your scratch paper. And guys, I want you to solve this question to the best of your ability. So what's the question? Well, guys, the question is simply this. You have 3 minutes. Figure it out. Can you borrow a calculator? I actually don't have one. You can use your phone if you'd like. Yeah, but I actually, well, the only calculator I have works in a different language. We'll talk. Hold on. So today is the 4th. Just answer the question. I know nothing of what you speak. Okay, guys, you got 2 minutes. Okay, guys. You got another 30 seconds to wrap up your thoughts and commit to a number. with the universal understanding that the one thing that you will all have in common is you will all be wrong. We'll just get that out on the floor right now. It is impossible for you to get this question right. No, we're not talking about why. We're just laying out the ugly truth. Why do you do any of this? So, see? That's right. Okay, guys, so why did I put you through that exercise? And the reason is this: because it creates confusion. All of a sudden, Josh is asking me, what's the date? And I'm overhearing you guys going through these conversations about, wait, how many days are in a year till, I heard someone mention leap year. Who was it? Olivia. What's up with leap year? What on earth does that mean? And we're talking leap years and how do we deal with that? And we've got minutes and hours and seconds and days and lions and tigers and bears, oh my. And guys, here is exactly the reason why we need to learn dimensional analysis. Because guys, bottom line is Mason hit it on the nose. Flippantly, Mason said, why do we care? And guys, the answer is we don't. Seriously, we don't really care how stinking old you are in seconds. What you're going to find out is that what we do care about is the process that allows you to figure it out appropriately. And guys, notice the answer is not correctly, it is appropriately. And guys, that's what dimensional analysis is all about. It organizes your thoughts, and heaven knows some of you could use that, right? And it allows you to come to an answer that is appropriate. So guys, regardless of what you have on your paper, we talked about the idea that no matter what you wrote down, it's wrong. The reason that it's wrong, and I know some of you understand this, is because literally the second you wrote it down, even if it was right, it is now 1 second wrong. Right? But guys, it gets even worse than that. Olivia, how old are you? No, you're not. Guys, and I picked Olivia because she started talking about, she was the leap year girl, so I figured. But guys, the deal is this: you understand that if somebody asks you how old they are, how old you are, and you say it's just my birthday, 46. If I tell somebody I'm 46, I'm lying to them, because all I'm telling them is I'm not yet 47, right? Because guys, what that means is you're in that year, you've crossed that milepost. Because when you're 1 year old. So when you're 46, it means you're 46 years old, but you're progressing into that 47th year. So when you tell somebody that you're 17, you're not 17. The only thing you're telling them is you're not yet 18. So guys, that's the problem. And this is the case in science as well as casual conversations around how old you are, is there's all sorts of room for misinterpretation and error. And that's what this dimensional analysis allows us to do, is create some rules that gets rid of the craziness. So what are the rules? Write them down. And guys, here's the deal. These are not really rules, they're steps. Now guys, this is the promise that I make to you. If and when you find these difficult, and when you come, because you're an engaged student, when you come to get help, if you come to me and it's clear that you are following these steps, I will kill or die to help you figure this out. But when you come to me and it's clear that you've blown all this off and you're just trying to free-form this, I am going to turn away from you and not help. So guys, the bottom line is this: I don't care what kind of calculator jockey you are. And I know a lot of you were able to solve the how old are you in seconds questions in your calculator. That's not the point, as Mason pointed out. We are not doing this to figure out how old we are in seconds. We're doing this to learn a process that if you don't understand it come next week, you're sunk. So guys, if you think you're above this, wait until next week comes. You will be incapable of solving the problems that we're going to solve on Monday without dimensional analysis. And if you don't believe me, ask people in my AP class. They do this every day. So guys, what are the steps? Step number 1 is this. Figure out your goal. Props to our good friend Stephen Covey. Start with the end in mind. Never mind. Although his boy is an amazing wide receiver and kick returner for the U. Good heavens, that kid's got wheels. Okay, anyway. Okay, number 2, figure out your starting point. Number 3, guys, and this is the part that I struggle with the most, draw a line. Because it always tends to slant because I'm not very good at drawing things. Then, guys, number 4. Once you've got your goal, your starting point, and your line, you are going to apply conversion factors. These conversion factors will be fractions that are equal to 1, and they must cancel in such a way to leave you with your desired units, which are your goal. Then, guys, you will solve. You'll do this by multiplying by what's on top and dividing by what's on the bottom, and then you will round your answer to the number of significant digits in your least accurate factor. So guys, this is going to be like shooting free throws. You are going to develop muscle memory. I have a deep-seated hatred for basketball that developed when I was in 7th grade, and they actually put me on the court and I scored a basket for the other team. That's the story. That's it. It's the only basket I made the whole game. It was an inbound, and I forgot where I was. Anyway, but guys, basketball, right? You step up to the line and you don't just huck the ball. You step up and you develop a rhythm. You dribble 3 times. You don't dribble at all. You dribble with 2 hands. You dribble with 1 hand. You spin. Whatever you do, you develop a rhythm. Well, guys, you're going to do the same thing here. You're going to develop a rhythm. And we're going to start developing that as soon as you're done writing this down. You've got to develop a rhythm. My ability to develop a rhythm actually depends upon my board working. We'll see. You guys caught up? Good heavens. I should have this installed by the time I go home today. Yeah, well, the problem is if they don't, I'm stuck because I've got to rip this down to put that up, and if that don't work, I got nothing. Except for a whiteboard marker. Exactly. Done now? These are like a herd of turtles. I guess the good part of this, though, guys, is you understand that these steps are important enough that you're taking the time to write them down. Keep them as a reference, because we're going to be referring to these. We're going to solve 3 of these problems today. We're going to go back and actually figure out how old you are in seconds. We'll use Olivia as our example. And then, guys, we're going to solve 2 others to sort of drive this idea home. And then you're going to have time to work on your homework, because as you would imagine, the way to get good at these is to do them. You guys done? Okay, so I'm trying to figure out the best. I'm going to just do this. All right. Let's have a moment of silence. Oh, crap. All right, hang on. This board is so messed up, it actually loses calibration every time. Wow. Wait for it. Okay. Come on, baby. Just one more day. That's all I need. If you make it through today, I promise I won't throw you in a dumpster. Actually, I probably will. You guys know that there's actually a website where you can buy old Alpine School District stuff at auction? Mr. Ellingford enjoys it. Ellingford is by far the oddest person I know. Okay, let's see how we do. So guys, it goes like this. The question on the table was, how old are you in seconds? And because we've been sort of picking on Olivia, let's say that we're all 17. We understand none of us is 17, even if you think you're 17. Because guys, you understand, right? There was, in fact, one moment in time when you were 17. On your 17th birthday, the exact second you were born. And after that, you ain't 17 anymore. But we'll use it as our example. So, with that said, guys, step number 1 is not the fact that we're 17 years old. What is it? It's our goal. And guys, this is the point where you got to be careful. Some of you think you've got this, and I know you well enough to know you don't. Focus. So guys, our goal is step number 1. If you don't know what we're talking about, reference back to those steps that you spent all that time writing down. So our goal, guys, is seconds. And you, right now, are going to invest the time in writing that down on the very far right-hand side of your page. As far right as you can go. Now, guys, let me just tell you right now, again, when you don't understand this and you come for me to get help, I'm going to look on the right-hand side. And if you don't have a goal written down, I'm going to walk away. Because you can't do this if you don't know your goal. Now, step number 2. Follow the line on your paperback all the way to the left. And now we need a starting point. Feel free to write down your age, but I'm going to use 17. Come on, baby. 17. Because I'm using Olivia as my example. Okay, now guys, step number 3. You are going to draw a horizontal line from your starting point to your goal. Why are we spending the time to do this carefully? Because this is all about organization. Guys, if you thought this problem was confusing with days and hours and minutes and seconds, wait until you see Monday. You got to get organized. So now, gang, draw a line, and we're ready for step 4. Applying conversions that have 2 characteristics. They are fractions equal to 1 that leave you with your desired units. So guys, this is the way you play the game. You ready? We want to be in seconds. We're in years. How many seconds are in a year? We don't know. So then the question becomes, what do we know about years that could get us closer to seconds, Paxton? Days. How many days are in a year? 365. Now guys, watch. Don't write this down. 1 year is equal to 365 days. Is that true? It is true. Now guys, check this out. What does equal mean? The same. This is the same as that. So now guys, and again, don't write this down. What about, let me do it up here. What about this then? 365 days over 1 year, or 1 year over 365 days. What are both of those fractions equal to? 1, because any number divided by itself is 1. And if these are the same, and you said they were, then these are fractions equal to 1. Do you now understand the first thing that it says under step number 4 that says fractions equal to 1? The top and the bottom have got to be the same. Now guys, let's look at the second characteristic. What does it say? Cancel to leave you with the units that you want. And guys, you all understand from algebra or secondary whatever that things that are on the top and bottom cancel, right? Now, that tells us which of these two fractions to use. Because if years are up here, years have got to be down here to cancel, which tells us we want this fraction. So we're going to go 1 year is 365 days. And now we have applied a conversion that gives us both rules. It is a fraction equal to 1, and it cancels. Guys, watch. I'm going to even switch colors if my board will let me. It cancels to leave us with units that are desirable to us. But are we done? No, because this is days and this is not days. Guys, that's important. Sometimes you're going to get into solving these problems and you're not going to know if you're done. How do you know when you're done? When this is this. That's how you know when you're done. So, how many seconds are in a day? We don't know. So what can we do with days to get closer to seconds? Hours. 24 hours is a day. Yeah. So which goes on the bottom? The 1 day or the 24 hours? 1 day, because it's got to cancel top to bottom. So 1 day is 24 hours. Cancel days, we're left with hours. Are we done? No, because we ain't at our goal. How many seconds then are in an hour? Oh, yeah, some of you know. Let's pretend like we don't. So we don't know. So what can we do? Go to minutes. So guys, in an hour there are how many minutes? In an hour there are 60 minutes, which goes on the bottom, the hour or the minutes. The hour, so it cancels. So 1 hour is 60 minutes. Hours cancel. We're left with minutes. Still not done. How many seconds are in a minute? 60. Again, canceling. 1 minute is 60 seconds. Minutes cancel. Oh my goodness, we're done. Guys, this is where you do step 4.5. Breathe a sigh of relief. Because guys, seriously, you're going to get into some of these problems next week and you are going to feel like you've won the lottery just because you can get the units to line up right. At this point, it seriously becomes a monkey with a calculator. So guys, let me explain to you how to do the math. This is in the last step. Not the last step, the first to last step. Guys, you don't have to think about how to manipulate the numbers. All you have to do is multiply by everything in the top and divide by everything in the bottom. So grab your calculators. Guys, there's two ways to do this. It doesn't matter because the algebra gods say the order of operations for multiplication and division don't matter. You could go multiply, 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 divide, 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 divide. That's fine. You could also go multiply, divide, multiply, divide, multiply. It doesn't matter. However you choose to do it. I like to go up and down. So guys, we're going to take 17. What are we going to do with 365? Multiply by 365. Now guys, let's talk about the divide by 1. Do we need to do it? Doesn't change the value. Let's not do it. Then we are going to multiply by 24. No need to divide by 1. We are going to multiply by 60. No need to divide by 1. We are going to multiply by 60. No need to divide by 1. And I get 5, 3, 6. Come on board. 1, 1, 2, 0, 0, 0 seconds. Can you guys confirm the number? Okay. Now guys, we are nowhere near done. And this is where you are going to learn something, even if you learn this from Laosa. Guys, the thing that we know for sure is this answer is wrong. Was this answer ever right? Once, for a second. But guys, even at that second, check this out, this answer was still wrong. And here's why. This is not true. 1 year is not 365 days. Some of you are thinking that it's a fourth because of the leap year. Did you know this is a leap year? So guys, A year is not 365 days, it's actually a little longer. So what we do is every 4 years, we make up for the quarter, the extra quarter day, and we have a leap year where we add an extra day to our calendar, adding up the fourths every 4 years gives us an extra day. But did you know that even that's not right? It's actually not 365, it's 365.24, which means that every 100 years, we skip a leap year. Yeah, guys, in the year 2000, remember when the world was going to end, Y2K, computers wouldn't know what to do? Remember that? That was supposed to be a leap year. But if you go back and look at your calendars, we didn't do a leap year in the year 2000 because it was 100th year, and we skip a leap year every 100th year to make up for the fact that it's not exactly 365.25. It's actually pretty smart. But guys, what does that mean? It means that even if we thought this number was right, it's still wrong. So what do? And guys, the answer is this. We think about significant digits. Ready? And I told you needed to go back over these. I pray that you did. So guys, focus with me because this is the tricky bit. We understand that this number's not right because these numbers are not actually correct. How do we deal with it? Well, guys, it goes like this. We need to figure out how many significant digits are in each of these numbers. And then we are going to round this number to the least significant digits up here. Get it? Okay, so watch. Do this with me. How many significant digits in 17? 2. Write it down up here for now. Eventually you won't need to, but for now you do. Now guys, 365 days in a year. How many significant digits in 365? 3, right? Now gang, let's talk. What about the 1? That does not limit significant digits, and here's why. This is a point of reference. You will notice that every one of these conversions has a portion of it that is a 1. 1 year, 1 day, 1 hour, 1 minute. Those are points of reference and don't limit significant digits. Ignore them. Now guys, watch this. How many significant digits in 24? Not 2. You're about to learn something again. Guys, this number does not represent 2 significant digits. How many does it represent? Infinite significant digits. Check this out. How many hours are in a day? 24. Is it ever 23.9? Is it ever 24.1? It's stinking 24. Guys, that number is perfect. And because this number is perfect, it doesn't limit significant digits. So now you're thinking, wait, what about 365? Is this perfect? No, that's why I spent the time to teach you about the fact that even 365.25 ain't right. Guys, this is not perfect. It's an approximation and therefore limits significant digits. This is stinking perfect, so you write the infinity symbol above it and realize that dude don't limit significant digits. So what about 60 minutes in an hour? Perfect. It's 60 minutes in an hour. That is perfect. And what about 60 seconds in a minute? Also perfect. Now we're ready to do some rounding. So guys, we are going to round to the least accurate factor. Is it the 2? Is it the 17 or the 3? Well, it's the 2. That's the fewest. So we've got to round this to 2. So here's 1 significant digit. There's 2 significant digits. What does the 6 tell us to do? Round up. So we go 5, 4. And then guys, what do we do with the rest of those decimals? Do we truncate or replace? Replace 0, 0, 0, 0, 0, 0, 0. And guys, this is what we know. We know that if you are 17 years old, you are 540 million seconds old. That's the best we can do given the accuracy of the original measurement, 17 years old, and given the accuracy of our conversions. Get it? Now guys, again, let's go back to what Mason said. We don't care, right? This is not about the answers right now. Guys, this is about the process. The answers become all shades of important next week. But for now, it's just about the process. You convinced of that? Okay. So guys, let's see what you learned. Next question. Brian weighs 125 pounds. Who's Brian? Doesn't matter. We don't care. We need to learn the process. So guys, if Brian weighs 125 pounds, what is his mass in grams? You, right now, do steps 1, 2, and 3 without me. Guys, do steps 1, 2, and 3 without me. I appreciate what Josh is saying about conversion chart. You need to do the steps. And if you're thinking conversion chart, you're thinking step 4 before you've done 1 through 3. Be careful. Guys, step 1, a goal. Step 2, a starting point. Step 3, a line. You could have. You could have put 5.4 times 10 to the 9th. That's fine. Same significant digits, though. Okay, guys, so let's see how you did. Step number 1 belongs on the far right-hand side. If you didn't do that, shame on you. What is our goal? Grams. So we can simply write G for grams. Now, guys, we're going to come over here on the left, and we need a starting point. What do we know about Brian? He weighs 120 pounds. 125 pounds. He's gained weight. Oh, for the love. Come on, baby. Oh, okay. Then a line, and we're ready to go. All right, Josh. Guys, here's the deal. What do we need to know? Well, we need to know how many grams are in a pound. We don't know. So, what we need is a reference chart. That's this. You will be welcome to not use this one on the test. I will give you a clean copy of it for the test, which means that you are now free to write on this, and it won't mean you're cheating during the test. Okay, guys, take a look at this chart with me because you got to understand how it's organized. You'll notice that it's broken into the English system. Again, one of my goals for the year is to get off the English system. I'm doing my best. Then the metric system, then the English to metric conversions. Then you'll notice in columns it's broken into length and volume and weight or mass. We'll use those interchangeably. Now, guys, take a look in the upper left-hand corner at the English length conversions. 12 inches is a foot. Really? Yeah. 3 feet is a yard. Really? Yeah. Go to the middle. 2 cups is a quart. Really? Go to the far right. 16 ounces is a pound. Really? Yeah. Guys, all of the English conversions are perfect. I would encourage you off to the left next to, well, anywhere around the English system to write down perfect. Why do you care that they're perfect? They have infinite significant digits. Now, guys, looking at the middle part with the metric conversions. Look at the top one. 10 centimeters is a decimeter. Really? Yeah, it is really. You probably didn't know that. 100 centimeters is a meter. Really? Oh, yeah. Looking at the middle. 1,000 centimeters cubed is a decimeter cubed. Remember that? Yeah, that's always true. And off to the right, 1,000 milligrams is a gram. Really? Yeah, really. Guys, these are perfect. All of the metric conversions are perfect and therefore do not limit significant digits. But now, guys, look at the bottom. English to metric. 1 inch is 2.54 centimeters. Really? Yeah, really. Guys, that doesn't get any better. That's perfect. That's why I wrote exact next to it. But look below that. 1 meter is 39.37 inches. Really? No. Look at the middle. A liter is 1.06 quarts. Really? No. Look at the right. A kilogram is 2.2 pounds. Really? No. Guys, none of the English to metric conversions are perfect, with the exception of the first one, 2.54 centimeters is an inch. So next to those, you may want to write not perfect, which tells you what? They limit significant digits on all of those, except for just that one. Yeah, okay. So guys, with that said, we are now going to think of this process as a journey. And guys, you have got to figure out how to take this journey. And our journey is from pounds to grams. So the way to approach this is to allow your eye to fall to this chart where you are going to find the pieces that are going to get us from left to right. And those, of course, will be under the weight column, right? So let's start looking for pieces. And so where is the first place your eye falls relative to pounds and grams? Pounds to... You guys want to fight it out? We got pounds to ounces and pounds to gram. Which one are we going to do? Or it doesn't matter. You can do it either way and we'll get exactly the same answer, which makes this test a pain in the butt to grade. Guys, there are multiple ways to solve many of these problems, and I've got to keep them all in mind when I do the key. Here's the thing that's really a pain in the butt. Depending on the route that you take, the number of significant digits that you get in your answer could be different. So tell you what, I'm going to go pounds to kilograms. Why don't some of you go pounds to ounces, and let's see where we meet up. So guys, here I go. Let's say this. If you've done this before and you feel comfortable with it, try going pounds to ounces. If you're just learning this and you need more support, join me pounds to kilograms. So guys, here's what I know from the chart. Which way does it go? 2.2 pounds is 1 kilogram. So guys, what am I going to put on the bottom? The pounds or the kilogram? Pounds, so it cancels. So now it's not a 1. It is a 2.2. And it's 2.2 pounds is 1 kilogram. So now guys, I cancel. My pounds cancel out. And I'm left with kilograms, but because I understand what I'm doing, I know that I'm not done because I haven't reached my goal. So now I go back to my chart and I try to find a relationship between kilograms and grams, and oh my gosh, there it is off to the right. 1,000 grams is 1 kilogram, and so guys, we know that kilograms are on the top here, so kilograms are on the bottom here. 1 kilogram is 1,000 grams. Kilograms go. I'm left with grams, so I know I'm done. So now I grab my calculator. But guys, watch. Now we need to divide. So I'm going to start with 125. And I am going to multiply by 1. No, doesn't change the value. But I am going to divide by 2.2. And then I'm going to multiply by 1,000 and not divide by 1. And I get 56818 grams. But guys, we understand that number's wrong because it doesn't have the right number of significant digits. So now guys, check this out and let me let you in on a secret. How many significant digits in 125? 3. Now here's the question. Actually, let me make it a statement. This number will never have infinite significant digits. Think about that. This number will never have infinite significant digits. Why not? Because it will never be a conversion. It will always be a measurement, and measurements are never perfect. So this will always have a number of significant digits. Now, what about 2.2 pounds in 1 kilogram? Is that perfect? No, it's English to metric. So it's not the 1 we look at, it's the 2.2, and that gives us 2 significant digits. Now, what about 1,000 grams in a kilogram? Perfect? Yeah, it's perfect. So that's infinite. So guys, how many significant digits do we get? 2. So rounding this to 2 significant digits, I get 57,000 grams. Now, for those of you that did it the other way and you went ounces, pounds to ounces, 16 ounces in a pound is perfect. And then you went ounces to grams, it's like 28.4 or something like that. And that's got 3 significant digits, and you would have 3 in perfect and 3, and you would actually get 3 significant digits in your answer, but it should be close to this. Is it 56,800? There you go. You get the idea? All right. Now, guys, one more example. And guys, don't get cocky. This last example, and I may have made a huge mistake here, this last example is a brand new skill. You're going, wait, we just learned a brand new skill. You're going to learn another brand new skill. But I got all excited because the professional cycling racing season started yesterday with the Tour of Dubai. And one of my favorite sprinters, Marcel Kittel, who's got really cool hair, actually won the first stage of the Tour of Dubai. And if you look it up on YouTube, it was an amazing finish. So, you watched it? So I wrote a question for Marcel. So guys, Marcel Kittel, actually, who was gone all last season because of an injury and no sponsors would pick him up because he was sort of a wild card. Although he did win the Tour de France in 12. He's amazing. Anyway, he returned this year from cycling after a year off from injury. Yesterday, he did actually win the first leg of the Dubai Tour. And in the final sprint, this is crazy, he actually reached a speed of 82 kilometers per hour. Only for about 20 seconds, but it was cool to watch. Here's the question. How fast was he going in miles per hour? So, guys, this is actually the reason I am trying to ditch the English system. My passion for cycling has me watching a lot of European television, and they don't talk about pounds, they talk about kilograms. And they get on there and they say the temperature, it's scorching today, it's 38. Turns out it's almost 100 in Fahrenheit, but I've got no friends, so I'm trying to learn. So let's see what we can do. But guys, don't start without me. I know that some of you right now are going, okay, I'm shooting free throws. I'm going to set my goal. You're going to do it wrong. So guys, talk through this with me. What is your goal? I'm not saying you're going to get the goal wrong. I'm saying you're going to represent it improperly. What's the goal? Miles per hour. Now guys, what does the word per mean mathematically? Divided by. So guys, watch. We're going to go miles per hour. Do not write this on the same line. You're going to go miles on one line, draw a line on the line, and hours in the bottom. Blow me off at your own risk. But guys, you're going to get in a world of trouble really quick. Now guys, we need a starting point. 82 kilometers per hour. So guys, you got to be careful. Follow this line back. And this is our 82 kilometers. And then it's per hour. Guys, notice what we did. We set up what we call a compound or complex conversion. Watch what we're going to do. We're going to draw this line back. And you know what I'm realizing? I may change this a little bit. Let's do this. Oh, you know what? Hold on. I got all excited about Marcel, and I'm realizing this is going to screw us up. So, back of napkin calculation, wait for it. I've got to do some dimensional analysis without you. 1 kilometer is 1,000 meters, and 1 hour is 3,600 seconds. So 82 times 1,000 divided by 3,600. We're going to change this. Let's change. Poop. I was close. Okay, so guys, give me an eraser. Okay, so guys, we're going to change this because, again, we don't really care, right? Although I'm excited about Marcel. We need to figure out how to do this math. So guys, this is going to be 23 meters per second. That's actually the same speed. It's just in meters per second. Okay, now we're ready to draw our line. So here we go. Guys, this is important for you to understand how to do. The rules haven't changed. What we have done is created what we call a complex conversion. Because guys, watch what we're doing. Don't write this down. But guys, to figure this out, we've got to convert meters into seconds. Or I'm sorry, meters into miles. But then we've also got to convert seconds into hours. And we're going to do them on the same line, and it doesn't matter which one we do first. So let's do the top first. Guys, how many meters are in a mile? We don't know. So where can we take meters to get closer to miles? Kilometers. 1,000 meters is a kilometer. So guys, the 1,000 meters goes on the bottom. Do you understand why? And the kilometer goes on the top, and meters cancel. Are we done? No, because kilometers are not the same as miles. So now we need to go kilometers to miles. How many kilometers are in a mile? 1.6. So 1.6 kilometers is equal to 1 mile. Oh. It was too good to last. Come on. In 1 mile, kilometers cancel. And guys, we are now left with miles. But we're not done. Because we now need to deal with the seconds. And guys, watch. This is new. How many seconds are in an hour? We don't know. But we can say 60 seconds in a minute. And guys, nothing changes. 60 seconds is a minute, and it still has to cancel. But guys, watch. If seconds are on the bottom here, they got to be on the top over here. So 60 seconds is 1 minute. And then watch how this cancels. It cancels all the way across the grid. So now we are in seconds, but we're not done because we need to be in hours. But we know that 60 minutes is 1 hour. Minutes cancel. And now, guys, watch. Miles are left. Hours are left. Those are our goal. So now we breathe a sigh of relief. And I would be willing to bet none of you could figure this out without doing it using dimensional analysis. You would get so twisted around in the conversions and the multiplying that it would fall apart. But when you do it this way, it's really easy and very organized. So now, guys, let's do the math. 23. Do not multiply by 1. Divide by 1,000. Do not multiply by 1. Divide by 1.6. Multiply by 60. Oops. Okay, multiply by 60. Multiply by 60. And I get 51.750 miles per hour. Now, guys, we've got to do significant digits. How many significant digits in 23? 2. How many in 1,000 meters is a kilometer? Perfect. What about here? 2. What about these last two? Perfect and perfect, so we get 2. So my little buddy, Marcel, was going 52 miles an hour when he hit the finish line. All under his own power. That's pretty scary. No, it was a flat finish. That's pretty good. Okay, so guys, one last thing before I turn you loose on your homework. Here's the thing you've got to understand. Whether you knew how to do this walking in here today or not, you've got to understand, I am really good at these. And you're not. And some of you are sitting there right now going, I'm money, I got this. No, you don't. The only thing you know for sure is you're good at watching me do them. So guys, here's the deal. You're going to get home tonight, and I'm telling you, you're going to get frustrated. But guys, don't freak out. Some of these are not as easy as I make them look. So what are you going to do when you get frustrated? Slow down. Hang on, guys. Listen. Slow down. Go back to the steps. Set a goal. Get your starting point. Draw a line. Then start to find conversions that work. If you don't find success with that, call somebody that you know they know what they're doing. If you don't find success with that, get here in the morning. Guys, seriously, get here in the morning, get an eye, get in here tomorrow, let's get you help. Because guys, when you walk in here on Monday, the understanding is you know how to do these. So the only mistake that you can make over the next 48 hours is blowing off this homework and not doing it. Because guys, if you walk in here on Monday without having done this homework, you will have dug for yourself a pit that you may not be able to get out of. So make sure you do the homework. Guys, we've got 20 minutes. The answers are on the wall. Do not ask me whether or not you should do these on another sheet of paper, because you cannot do the steps on the paper that you have in front of you. Grab another sheet of paper, write big, take your time, do quality work, and let me know what I can do to help.